As we discussed, one very important aspect of cloud is virtualization. Now for the next few minutes, we would be totally focusing on what is this technology and how does this become a breakthrough for cloud. If you remember this slide we saw earlier, we talked of cloud computing having three basics underlying. One was the grid computing, the second was utility computing, and the third one was virtualization. That's exactly what we are going to be discussing now, virtualization. As per the Wikipedia, obviously Wikipedia also now defines cloud and virtualization in a lot of ways, but Wikipedia by default says that virtualization is a technique for hiding the physical characteristics of computing resources from the way in which the other systems, applications, or end users interact with those resources. Now, this has been there traditionally too, when the IT was being taken to elevated to that levels where the user should not really be bothered about how are you provisioning servers, where is the software coming from, what is the underlying technology. No, they only wanted to use the software. But today it has become a mandate in the cloud environment. So to make it a little simpler, the way we look at it is abstraction of the physical resources in order to run multiple operating systems on the same underlying hardware. So the hardware remains same. We can have multiple OSs, we can have multiple slices of applications, and basically each slice would be working as a server on its own, though physically the number of servers might be lesser. So as a part of introduction, let's read this. Virtualization is the simulation of the software and or hardware upon which other software runs. The word simulation. Why? We will see when we look into the architecture of virtualization. This simulated environment is called virtual machine. Each virtual machine can run its own operating system and applications as if it were in a physical machine. That's what I said. This is being referred to as a server in this context. So it is way to run multiple operating systems on the same hardware at the same time. And this is just one of the reasons why we would use virtualization. For example, Windows and Linux both can run on the same laptop at the same time. So you almost have two laptops. For the most simplest understanding, virtualization would always be separation or segregation. The separation is so abstracted that you don't bother from where this virtual aspect has come into picture, but you would only use this. Historically, how did virtualization begin? In 1960s, IBM started coming with large servers like M44, 44X. Now these servers were so huge that people could not consume all the resources. So that is where they started doing virtualization so that they could create partitions and they could use it for different aspects as if it were multiple servers within a single box. But as the technology kept growing and the x86, which is the Intel kind of chip, started coming up, so these technologies, the older chipsets of IBM really started dying. x86 was so cheap, people again forgot about virtualization in mid-80s to 90s. But then, once again, VMware came back and created virtualization on even this x86 chipsets. Now, before we even get into what is virtualization, why should we virtualize? If you actually look through some of those analyst reports, the power consumption, the cooling consumption of the servers is so high that it attributes to close to about 18 to 22% in different years to the overall costing of a data center, which is substantial, which is huge. So if the number of physical servers reduce, if their heating up reduces, so this cost can drastically be brought down. Secondly, newer and newer technologies, newer and newer softwares come up, but there are organizations, there are setups who still want to use some of those softwares which they have built in-house or which has been there with them for a very long time, which are known as legacy softwares. So if the new OSs do not certify them, how would they run? You still need to run one more slice or one more virtualized layer of operating system which would still allow this legacy software to run. There are so many softwares which you don't want them to interact with the OS because it could actually create damage on the OS. You can actually sandbox them because then the whole damage is only at the virtual machine layer and it has got nothing to do with the underlying operating system. Multiple operating systems. We took the example of legacy software, and even otherwise you might want certain enterprise applications to run on a Solaris. You might have certain mid-size applications which you might want to run on Linux because of their certification reasons, because of the way they behave, because of performance reasons, and there might be certain applications which you might still want to run on Windows Server because of the price points. So how would you actually manage this on a single server, because the size of the servers is still huge. The amount of compute which they deliver is huge. So you would want to use them for multiple purposes. Besides that, debugging and performance monitoring, etc., it has to be done individually at each level. Otherwise, it would actually remain at a server level. Even if a particular operating system crashes, what used to happen is the application would not run because there was no operating system. But now that can be contained. When you need a migration, you need a downtime. People talk about 24/7 operations, which means even when they are doing a migration activity or they have a maintenance downtime, the system should be up. So basically, make the environment more agile, and to keep up with the agile transformation of the business and technology, there are two key technologies. One is virtualization, which is the ability to run multiple operating systems on a single physical system and share the underlying hardware resources. This does not mean that it's just a single physical system. You could be having one VM spanned across two physical systems. You could be having multiple physical systems, having different instances of virtual machines, etc., etc. And from the cloud perspective, it is the provisioning of our services in a near on instant on demand manner to allow the scaling up and down of resources. That is where if you have VMware slices or if you have virtualized slices, you would actually be able to scale up and scale down by adding those slices as and when required. Traditionally, what used to happen? There used to be a hardware which was a physical box or a server. You used to have its own storage. You used to install the operating system, whichever you required, a Windows environment or a Linux environment, a Solaris environment on top of it. And then you used to have applications which could run on that particular operating system. If tomorrow you decide to change the operating system, the application had to be recoded. Every box had its own significance. So here if you see, the first box was basically for web server and application server. The second box, the database server, is the third box, and the other administrative applications like emails, exchange, etc. is the fourth box. Which means for running a particular application like an email, if that hardware is dedicated, it would not do anything else but only run those emails and windows. Now, for an instance, the application server goes down. You have the web server on, you have the database server on, but the application will stop responding because the application server is down. Be handled by clustering mechanisms too.